In this unit, we're going to be talking about several different families of functions. A family of functions is a group of related functions that share a common parent function. A parent function is the simplest function of a family of functions. And you'll see down here, there are 6 of them that are listed. Each of the names that are bold is the name of each family. So the families we're going to be talking about are linear, quadratic, cubic, absolute value, square root, and rational. And then there's the parent equation or the parent function. And those are where it says parent, and then it has f of x equals. So these are the most simple form of an equation in each of these families. And then the graphs that you see are the graphs of those parent functions. So that's the kind of what the standard of that graph from that family always looks like. We're going to focus a lot on domain, range, and end behavior of all of these graphs that we're going to be looking at. Domain always refers to the possible x coordinates that you can have. What you should think is that if I extend this graph far enough, can I reach the left or the right edge? And are there any places on the x-axis that I cannot touch? Range is almost the exact same thing, but now we're talking about y values. So it refers to all the possible y coordinates you can have. So you should be thinking, can I reach to the top and bottom edge, or can you reach up and down? And are there any places on the y-axis that I can't reach? Finally, end behavior is talking about the ends of the line. So every line has 2 ends, the left side and the right side, and each side will either be going up, down, or straight across. Every line has 2 end behavior statements, one for each side. So for example, you might say that on the left side, the line goes up. So that would mean that as you're talking about your x values, as your x goes to negative numbers, the line goes up. So the y values go to positive numbers. So how you would write that, and let me write this again, x goes to negative, y goes to positive. As you would write that like this. You always have your x statement and a y statement. So you would say as x goes to negative infinity because you're going to the left side, and the y goes up, so the y would be going to positive infinity. Another example is if you're looking at the right side of the line, so as x is going in the positive direction, the line goes down. So that would mean that your line is heading towards the negative y direction. So you would write that like this. As x goes to the right, so that would be positive infinity, y goes down, so then y would go to negative infinity. For these examples, we're going to use the graph to identify the function, family, domain, range, and end behavior. So to identify the function family, this is something you're going to have to pretty much have memorized. You need to be able to look at those 6 graphs that are on the front page and have a general idea of what the shape of each graph looks like, so that when you're trying to identify, you'll have an idea of what family it comes from. So for number 1, it's a line, so that means that this is coming from the linear family. For domain, what I'm trying to imagine is if I stretched this graph out forever and ever, would it eventually go all the way left, or would it go all the way right, or both? Now, if I stretch this line all the way out, it would keep going to the left as I go up, and it would keep going to the right as I go down. So this would eventually cover everything. So what we say when it would cover everything is that the domain is all real numbers. And I'm going to write this off to the side because we have a symbol we can use instead of writing this out every time. It's a capital R with 2 vertical lines instead of just 1. So our domain would be all real numbers. That means it covers everything. For the range, very similar. If I extended my line it would keep going up forever and ever, and it would keep going down forever and ever. So the range is also all real numbers. The end behavior is the trickiest part, and what I like to do is pretend like I'm on the line in a little roller coaster car. So this is me riding on the line here. So their end behavior, your answer will always have two parts. The first part will always be talking about as x is going to infinity, and the second part will always talk about as x goes to negative infinity. And what that really means when you're talking about x going to infinity, that really means as x goes to the right. And when x goes to negative infinity, that's really saying when x goes to the left. So up here, as I go to the right, that's where x is going towards infinity, and left would be towards negative infinity. So as I'm going to the right, so if I'm on my roller coaster car and I want to head towards the right side of the graph, I would also have to be heading downwards on my roller coaster car. So I have to stay on the graph, but if I'm going right, I would also be going down. So that means our answer here is that as x goes to infinity, or as x goes to the right, y goes down, which is towards negative infinity. And now if I want to do the same thing, but I'm talking about now going to the left, my roller coaster car, if it goes left, would also have to be going up. So that means that as x goes towards negative infinity, my y value is going towards positive infinity because we're going up. For question 2, if you go back to one of those first slides and you look at the pictures of all the families, this is a cubic function. So that is my family. Domain and range are going to be really similar to number 1. If I extend this graph to go forever and ever, it's going to keep getting wider and wider, which means it is going to cover all the x values. So my domain would be all real numbers. Similarly with my range, if I extend my graph, it's going to go up forever and down forever. So the range will also be all real numbers. For my end behavior, I always start with my same two things as x goes towards infinity and negative infinity. So I'm going to imagine myself on a little roller coaster here. Okay, so if I go towards infinity, so to the right, that would mean I would also be taken up on this graph. So towards the right would also be up. So that means that the rest of my answer, as x goes to infinity or to the right, my graph goes up or towards positive infinity. As I go to the left towards negative infinity, I would be going down on this graph. My y values would be getting smaller. So that means that as x goes to the left, my y values get lower. So my y's would go towards negative infinity. Number 3, the family is quadratic. It's called a parabola. The domain is all real numbers because if I extended my lines on each end of the parabola, they would keep getting wider and wider. That means they would cover all of the x values. Range is a little different now because if I follow my graph up, it's going to go on forever and ever. But if I follow my graph down, it has a stopping point. So this point right here, that's the lowest y value that we will get to. So what we're going to have to do is write an inequality. So I know that the lowest y value that my graph gets to is -4. So we use y because we're talking about range. And I know that it's going to use -4. And all of my y values are -4 or greater. So I'm going to say that my range is that y's have to be greater than or equal to -4. My end behavior, I'm going to set up so x goes to infinity, x goes to negative infinity. And then I'll draw myself here on the parabola. Okay, so as x goes to infinity, or as x goes to the right, if I was to go to the right on my roller coaster car, it would take me up. So that means as x goes to infinity, y also goes to positive infinity. If I wanted to go to the left, so towards negative infinity, my roller coaster car would have to go up again. So that means that my answer here is the same. So as x goes to infinity or negative infinity, both of my y values are going up. All right, number 4, this is an absolute value family function. The domain would be all real numbers because if I extended this graph left and right, it would go forever and ever. The range now is going to be similar to the parabola, but now instead of there being a low point, we have a high point, which is at positive 2. So now I'm going to have my y and positive 2, but now everything is less than or equal to 2. The end behavior we can set up because we know each problem will always start the same way. And then if I take a look at my graph, so I'm going to put myself on the roller coaster right here. Okay, and maybe I actually should have put my roller coaster right here at the top. But anyway, if I follow this to the right, my y values will be getting smaller. So that means that as x goes towards infinity, y goes towards negative infinity because my numbers are getting lower. And then if I followed this to the left, and the reason maybe I should have put it at the top is because if I follow it to the left, I'm going to be going up for a little while, but then I'm going down. So you're not really focused on what you're doing on the short term. You're focused on what your roller coaster would be doing as you get lower and lower and lower. So my roller coaster, if I go to the left, will also be going down eventually. So my answer here would also be that y goes to negative infinity.